Hi everyone. This is my mini lecture for this week. This week it'll be on testing. So let's just get started. So this week we're going to talk about testing, and you have a number of articles and short videos, recordings to listen to. So I'll just emphasize some of the key points for the week. So first of all, it's important for you to understand the different types of tests that are available. And second, it's important to understand the importance of the accuracy of the tests and some of the trade-offs that have to be made between accuracy and the speed of getting the results. So you'll see in the video by the Food and Drug Administration, there's two broad groups of types of tests for COVID-19. The first is a group of diagnostic tests. And so these are tests that tell you whether or not you're infected with the virus. And the second group of tests are called antibody tests. And the antibody tests are tests that are done in your blood, and they don't tell you whether you're actively infected. What they tell you is if you were infected in the past, and after the period of infection, your body produces these antibodies in response to the infection. And so the antibodies are circulating in your body and can be measured. So it tells you that you were infected in the past. There's a lot of discussion now about what these antibody tests mean in terms of whether or not you're protected against being infected again. And so it probably, if you do have antibodies, it means you do have some immunity, but it's not clear how long that immunity will last and how effective it is. So therefore, even if you are antibody positive, it's recommended that you use all the same precautions, wear masks, social distancing, everything else. So we're going to focus now on the diagnostic testing because that's the testing that's really key to controlling the pandemic. And as we know, not everyone has the same kinds of symptoms or the same level of symptoms. Sometimes the symptoms are very mild, and so it may not be clear to someone that they actually have the disease. So therefore, one of the big discussions and debates has been about whether or not we have enough testing in order to control the virus. Because unless we know that people have the virus, then we can't adequately do isolation, contact tracing, and all the things that you've learned about before this. And so researchers believe that we have enough testing when only 1 to 3% of the tests that are done come back positive. So that means for every positive test, we have to do a lot of testing. So right now, we have about 1,000 new cases a day. So that would mean in order to have an adequate amount of testing, we would have to test about 100,000 people throughout the country in every single day. So that's a lot of testing, and it's been a big challenge to figure out how to get that level of testing and how to make it work. So one of the big challenges with testing, since we need so many, is that it's very slow to get the results. So these more accurate tests have to be done in specialized laboratories, and there's not enough specialized laboratories at this point. So therefore, it sometimes has taken up to 10 days to get the results. And that's, of course, a big problem because some people might isolate themselves when they have the symptoms, but other people, and probably most of the people, I would think, wait until they get the results back of their test to really take it seriously. And looking at this diagram that we saw last time, if a person is symptomatic in this period here at about day 10 or 12, that's when they may go get a test. And so if it takes 10 days for the test to come back, that takes you all the way up to day 21 or 22. And so this entire period, when a person is most infectious, it means they don't have the results of their tests. And so, as I said, if people think they're infected, they should self-isolate, but many people don't, so they're just circulating around. So it's a big problem, the fact that tests are taking so long to come back. And so people have been trying to, in addition to producing, developing more of these highly accurate laboratories, the thought is to develop other tests that can be done, the results can be gotten much more rapidly, even if they're a little less accurate. And so this is a test of the saliva test. And so you can see this woman here is spitting into a tube, and that saliva then goes to a small portable machine that can be in a doctor's office or someplace more locally, and it'll give the results much more quickly, like within an hour or so. And so you'll read an article about the saliva test and how that's being used in college campuses and other places, and there's a lot of hope that this might be an answer that would help things. But it's very important that you understand this concept of what it means to be accurate. So these tests are very quick, but they're not as accurate as the other test called the PCR. So what does accuracy mean? So this is just an example to understand it. So each one of these blue dots represents someone in a population. So there's 100 of these dots here. And so we're wondering, which of these people are possibly sick with COVID-19. And so we can look at this example. And so in this population of 100 people, there's 10 people who have the disease, and those are the people with the green dots. So there's 9 here and 1 other person there. Okay, so we test these people, and what happens is all these other people come back negative, and these 10 people come back positive. Okay, so there's one person who's actually not positive, who's told that they're positive, but 9 of the people who are positive, they're accurately identified. But there's one person over here who is actually infected and wasn't identified with the test. So what we say here is that the test accurately identified 9 of 10 cases. And we use this word sensitivity is the technical word that's used. So the test sensitivity is 90%. So it's just 9 out of 10 cases is 90%. So this is the minimum that the Food and Drug Administration requires of the PCR tests. So the PCR tests accurately identify 9 of 10 cases, and they only miss this one person here. However, as we said before, it takes 10 days. So all these 9 people may in fact be walking around in the community while we're waiting for those tests to come back. So one thought is, would we be willing to have a test that's less sensitive, less accurate, if we actually get the results more quickly? And it was a lot easier to do the testing. So what we see here is in this less accurate test, it may be that only 8 of the 10 cases are accurately identified, and 2 people here are still in the community. However, the thought that people have is, if this testing is really easy to do and super quick, then maybe it's okay that you miss these two people, because what you can do with a quick, easy test is test people repeatedly. So for instance, if these 100 people were teachers and you decided that you wanted to test teachers, say once a week with the saliva test. So you might miss these two people, but if you're doing tests frequently, then you would actually identify these people most likely in the next test. So that's the debate going back and forth about accuracy and speed. It's an important question, and it's something that we'll be talking about more and thinking about, but it's very important that you understand these two concepts of the different kinds of testing and what it means to have an accurate test, and what the level of accuracy means. So have a nice week, and don't forget we'll be meeting on Tuesday instead of Monday, because of the Jewish holiday. Thanks a lot. Bye-bye.